If we can establish that there is a variability of methane emissions between New Zealand's dairy bulls that can be linked back to their genetics, the opportunity is awesome to be able to utilise this variability to breed cows with lower methane emissions. Fantastic. The trial announced will involve dairy breeding bulls and is believed to be a world first, and is being run by Livestock Improvement Corporation, LIC, and CRV Ambreed, which together are going to collaborate to Together, they do sire 90% of New Zealand's dairy herd, and they're collaborating on this project. The project that is funded through the New Zealand Agricultural Greenhouse Gas Research Centre as well. So joining us now in a double header is Richard Spellman, Chief Scientist for LIC and geneticist from CRV Ambreed, Mr. Phil Beatson. Welcome, gentlemen, and thank you for joining Serious Country tonight.
Yeah, it's a pleasure.
Okay, Richard, I'll kick this off with you. How long ago did the concept of this begin?
Yeah, Sarah, so it probably about 2 years ago, so we had the opportunity of a discussion with CRV, so Phil was up our way and we talked about, this was an issue that was facing us as an industry, and we were very keen that the two breeding organisations really spent time together and developed a protocol where we'd actually take an industry approach rather than being sort of competitive in the science, where we can compete in the marketplace, but let's bring our two science teams together. So Phil, myself, and another scientist, Lorna McNaughton, we travelled around the world and looked at what other people were doing, certainly in dairy cattle, but also in other species, of how they were measuring methane and how they were going about trying to address this problem. And after that trip, we came back and we took the best of what we saw from around the world and came up with a trial that we have started this year.
Phil, why is a project of this significance important and will contribute in the long run to us reducing our overall greenhouse gases?
Well, New Zealand has some obligations under the various climate agreements to reduce our emissions. And agriculture makes up approaching 50% of New Zealand's emissions. So there's a requirement for agriculture to reduce the emissions. And dairy, of course, is one of those major agricultural activities in New Zealand. So reducing dairy's impact is critical. And we see genetics to reduce methane per kilogram of feed eaten as certainly a stretch, but an activity we have to pursue in New Zealand agriculture to meet its emissions targets.
So Richard, how do you go about measuring inputs and then of course that output, that methane?
Yeah, so it's a really important thing that one needs to do. So two key things for us, firstly is measuring feed intake. And one of the issues that we have in New Zealand is our animals are outdoors and eating grass predominantly. So, and to estimate feed intake from a grazing diet is nearly impossible to do accurately as we need to do. So what we've done is we've taken the animals, in this case the progeny test bulls, and put them in to a barn type system. And so LIC, we've built a barn and CRV have one existing. And we're measuring, so we're giving them lucerne pellets. And the reason we're choosing lucerne is from previous research that we've done with Dairy New Zealand, that's the most comparable one that we've had to pasture. And also means you can be very objective in the measurement. So we're feeding the animals pellets and we measure every time that they visit the feeding bin of how much they've eaten. So the feed intake's really important. And then the second one really is measuring the methane output. And so around the world, we saw probably the best way of doing that in this for livestock was a system called the LIC system, and it comes from the United States. And so we have a special pellets on, or treats really for the animals in this contraption. And so they can go and visit the LIC, the green feed machine. And at the time when they just eat a little bit of feed, we capture their breath. and that's captured in their breath, because that's where 95% of methane emissions occur, and we can measure quite accurately their methane emission. And if they visit that system 5 or 6 times a day, we get repeated measures through the day, and that means we get a very accurate measurement of both their methane emission, and also we measure their intake. And as Phil was saying before, then we can look at if there's differences in methane emission per kilogram of dry matter that each of these animals are eating.
Is it relative to grass? I mean, sometimes when I eat certain foods, the smell changes a bit. So methane is equivalent to what it would be if it was grass, these pellets?
Yes. So the work that we've done previously with Dairy New Zealand on a feed conversion efficiency is that feeding the lucerne pellet is the most comparable way to feeding pasture, and it's far more objective in the measurement that we can undertake. So yes, they are comparable, absolutely.
Phil, Harry Clark, the director of the New Zealand Greenhouse Gas Research Centre, is very pleased to support this project. How important do you believe science collaboration is in areas of such big challenges?
Well, this particular project would be extreme, assuming that it runs its course, as we expect following this year's pilot trial. It's going to be an expensive undertaking. It's to the national good that it is done, but it's probably very expensive for individual companies to take part or to fund themselves. So having a collaborative approach with industry, with New Zealand government funding through greenhouse gas is critical, and we've got to do a good job and work with Harry to make sure we do it as well as we can. I'd just like to expand that conversation a little, to pick up something that Richard said earlier. When we visited scientists at several institutions in the Northern Hemisphere a couple of years ago, one thing that struck me, and I think Richard and Lorna, was the international willingness to collaborate on this really important topic. So it's not just LIC and CRV. Richard might like to comment, but I think there's real goodwill internationally on this.
Yeah, Richard, absolutely. I mean, this is a global project potentially as well.
Yeah, it certainly is. So there are certainly some of our collaborators in Ireland, so they are doing similar work as well at the stage in beef animals, and Australia, Canada, and the Netherlands as well. So, Phil's right. This is a collaboration that we're certainly starting out domestically, and we will then look through time to combine our data sets potentially with others around the world to enhance everybody trying to reduce methane outputs.
Thank you so much, gentlemen, for taking the time to join us. Phil, sorry, I'm really sorry we have to go, but I really appreciate it. And if you'd like to find out more about this project, head to farmersweekly.co.nz. There is an article up there all about the wonderful project that is a collaboration between not only LIC and CRV Ambreed, but of course utilising the best brains in New Zealand, Abacus Bio, Ag Research, Dairy NZ. There's a number of them as well. This is a very exciting time, and great to hear that we are, again, world leaders. We've had a lot of world leaders on the show. That's because you're watching Sarah's Country, and that's how we roll.
This is Sarah's Country.